Welcome to today's Explainer. We are stepping way back in time today to uncover the absolute monumental legacy of a 9th century Persian scholar. Now, his name might not immediately be on the tip of your tongue, but I guarantee you his life's work is quite literally beating at the heart of our daily digital lives. We're going to see exactly how one man's pursuit of practical problem solving in the ancient world fundamentally built the architectural framework for modern mathematics, computer science, and even global geography. It is an amazing story. Okay, let's dive into this. What exactly connects the complex software code running on the smartphone in your hand right now to the, let's be honest, sometimes frustrating math classes you had to take in high school? Well, the answer lies hidden within two words that we use all the time: algebra and algorithm. Both of these terms, which represent the absolute pillars of modern technology and mathematics, trace their origins back to a single mind working over 1,200 years ago. Meet Muhammad ibn Musa al-Khwarizmi. He was born around the year 780 in Khwarizm. That's an area just south of the Aral Sea in modern-day Uzbekistan. And al-Khwarizmi's brilliance definitely didn't go unnoticed. He was actually summoned to Baghdad by the Abbasid Caliph al-Mamun, who was a massive patron of knowledge. Once there, al-Khwarizmi was appointed as the court astronomer and the head of the library at the legendary House of Wisdom, or Beit al-Hikmah. Think of this place as the ultimate ancient think tank. It was an incredible research academy where scholars from all different faiths gathered to faithfully translate the greatest ancient works of Greek, Sanskrit, and Pahlavi into Arabic. It was, without a doubt, the intellectual center of the world at the time. And this brilliantly illustrates just how productive he was. Al-Khwarizmi's life was defined by sheer world-changing output. Working right in the middle of the 9th century Islamic Empire, he hit milestones that completely modernized both mathematics and geography. Around 820, he writes his groundbreaking book on math, Hisab al-Jabr wal-Muqabala. Then, just a decade later, in 830, he completely pivots to mapping the known world with Kitab Surat al-Ard. Up until his death around 850 in Baghdad, he spent his life essentially redefining these disciplines from the ground up. But let's look a little closer at that first book from 820, because the title holds a very, very famous word. Here is the fascinating etymology of a word you definitely know: Al-Jabbar, which of course we now know as algebra. In its original Arabic, from the verb jabara, it literally meant the reuniting of broken bones. Crazy, right? Ironically, when the word first entered the English language, it was actually used as a medical term for setting fractures. But al-Khwarizmi took this anatomical concept of restoring and reuniting and applied it directly to mathematics, specifically to the science of equations. He used al-Jabr to mean the restoration of an equation by transposing negative quantities to the other side to make them positive. Now, what's really critical to understand here is that Al-Khwarizmi didn't invent algebra as some abstract theoretical torture device for future students, not at all. He founded algebra as a completely independent, highly practical discipline designed to solve the everyday, complex problems of the Islamic Empire. Daily life back then required meticulous calculations, things like dividing inheritances according to very complex laws, settling lawsuits, managing trade and commerce, and partitioning land. He wrote his book to serve the immediate practical needs of the real people around him. And to really humanize this mathematical genius, we have to look at his underlying motivation. He explicitly stated that he wrote his algebra book to serve his community. And as he put it, he considered his work as worship to God. For Al-Khwarizmi, bringing order, logic, and practical problem-solving to society was a deeply spiritual endeavor. He was trying to bring balance to the world, much like he was bringing balance to his equations. To achieve this balance, he famously gave analytical and geometric solutions for linear and quadratic equations. Take this historical problem, for example: x squared plus 10x equals 39. This specific equation became so wildly famous that it was repeatedly used as the standard example by later mathematical writers for centuries. Al-Khwarizmi didn't just solve this algebraically, though. He actually provided geometric proofs with figures, acting as one of the true founders of analysis as distinct from pure geometry. So how exactly did his method work? Well, he essentially built a foolproof, step-by-step method. He started by defining the unknown, calling it the thing, or shay, or the root, jither. And actually, that is exactly where our modern mathematical term root comes from. Then he applied al-Jabr to restore the equation by moving negative quantities over to make them positive. Finally, he used al-Muqabala, which translates to reduction or balancing. That just means the process of eliminating identical quantities from the two opposite sides of the equation.
Because he so systematically introduced these steps, treating algebra for the very first time as its own completely independent discipline, he is rightfully celebrated today as the father of algebra. Now, what's really interesting about this slide is how Al-Khwarizmi also brought a massive leap in efficiency to the world. Before his work, numerals were often depicted clunkily using letters of the alphabet. Just think about the limitations of Roman numerals. It's a nightmare for complex math. So Al-Khwarizmi championed the Indian system of numerals instead. He introduced positional decimal notation to the Arab world, and crucially, he explained the mathematical use of zero. This was huge. It completely transformed the concept of a number from just a fixed arithmetic quantity into a variable element that could actually be manipulated in complex equations. His groundbreaking work synthesizing Greek and Hindu knowledge into Arabic eventually made its way west. Now, his original Arabic book on arithmetic was actually lost to history, but thankfully it survived via a 12th century Latin translation discovered in the University of Cambridge Library. The translated text, titled Algoritmi de Numero Indorum, opens with a very famous phrase. Spoken has Algoritmi. Let us give deserved praise to God, our leader and defender. And here is the absolute aha moment. Think about that word, algoritmi. When European scholars translated his texts into Latin, they basically distorted his name, Al-Khwarizmi, into algorithmi or algorithm. Over time, algorithm became the old word for arithmetic, and eventually, it evolved into the word algorithm. That's right, the very word that powers modern computer science, search engines, and artificial intelligence is literally just a medieval mispronunciation of this 9th century Persian scholar's name. There's no way around it. That is just incredibly cool. Let's move to and see how this builds, because his genius wasn't confined to just mathematics. Al-Khwarizmi was also a peerless astronomer and geographer. He developed detailed astronomical and trigonometric tables containing the very first Muslim tables for the sine function, and later he expanded that to the tangent function. He even collaborated on a massive project ordered by the Caliph to measure the volume and circumference of the entire Earth. Plus, he made vital physical contributions to the mechanics of clocks, sundials, and astrolabes. His tables were so incredibly precise that they were translated into Latin by Adelard of Bath in the 12th century, and later, they even made their way into Chinese. Over in the realm of geography, he looked at the 2nd century work of the famous Greek scholar Ptolemy, and basically saw some serious room for improvement. So in 830 CE, Al-Khwarizmi wrote Kitab Sort al-Ard, or the Form of the Earth. He completely revised and corrected Ptolemy's flawed views. He produced immense tabulated lists of longitudes and latitudes for cities, mountains, oceans, and islands, all categorized by geographic climes. Through this exhaustive, painstaking work, he and his team produced what is widely considered the first map of the heavens and the earth drawn by Muslims. So the crucial point is that his work didn't just stay isolated in Baghdad. It traveled, essentially seeding the European Renaissance. His 9th century Arabic texts were meticulously preserved and translated into Latin in the 12th century by scholars like Gerard of Cremona and Robert of Chester. Because he so clearly distinguished algebra from pure geometry and introduced the decimal positional numbering system to the West, his books didn't just sit on a dusty shelf gathering cobwebs. They were actively used as the principal mathematical textbooks in European universities all the way up into the 16th and 17th centuries. To summarize his unmatched legacy, we can look to this powerful quote by the historian Philip Hitti. He notes that Al-Khwarizmi, quote, influenced mathematical thought to a greater extent than any other medieval writer. Through his role at the House of Wisdom, he synchronized the mathematical brilliance of India and Greece, added his own revolutionary concepts of reduction and balancing, and packaged the whole shebang in a way that would quite literally educate the globe for half a millennium. Which leaves us with a profound question to ponder as we wrap up this explainer. Think about the device you are using right now. Think of the software that connects our entire modern world. How many modern technological breakthroughs are standing squarely on the shoulders of this one 9th century scholar from Baghdad? Without his introduction of zero, his founding of algebra, and the algorithms that literally bear his name, our modern digital reality simply would not exist. Thanks so much for joining me today, and keep learning.